Hey everyone, welcome to this explainer. Today, we're taking a geological field trip to uncover the absolute massive forces shaping our planet. Usually, when we think of Earth's architecture, we picture tectonic plates slowly crashing together. But today we're focusing on the planet's fiery plumbing system, the one that runs both high above us and miles deep below the ground.
Right, let's just dive straight in. We're not just talking about the classic fiery mountains you see in Hollywood movies, although don't worry, we'll definitely cover those. We are going to explore the incredible, completely hidden structures right beneath our feet. We're looking at what happens when molten rock violently breaches the surface, and equally importantly, what happens when it gets trapped and solidifies in the dark, forming giant underground saucers of magma and massive rock walls.
So, here is our itinerary for today's explainer. We'll kick things off with the surface giants, move into lava floods and ocean ridges, take a deep journey beneath the crust, and wrap it all up with hidden underground landforms.
All right, part 1, the surface giants.
Let's start up top, looking at the massive structures built by erupting magma. When lava hits the air, it cools into igneous rock, but the actual shape of the mountain entirely depends on the lava's, well, personality. It's really a tale of two mountains. On one hand, we've got shield volcanoes. These are formed by fluid, low-explosivity basalt that spreads out easily to create really gentle, sweeping slopes. On the flip side, composite volcanoes. This lava is cooler and way more viscous, basically sticky. Because it's so thick, gases get trapped inside and boom, you get highly explosive eruptions. Instead of smooth flows, they blast out large quantities of pyroclastic material and ash, which piles up around the vent in distinct layers. That layered look is exactly why we call them composite volcanoes.
Now, here's a wild fact about those shield volcanoes. Despite those gentle, rolling slopes, they're actually the largest volcanoes on Earth, if we exclude massive basalt flows, of course. Think of the Hawaiian Islands. Those are textbook shield volcanoes. Because their lava is incredibly fluid, they aren't super explosive. The lava just kind of fountains out and builds up a cinder cone right at the top. Honestly, these gentle giants generally only get dangerous if water somehow manages to seep into the vent, flashes into steam, and basically blows the whole structure apart.
Okay, let's jump to the absolute extreme end of the danger scale, the caldera. These are hands down the most explosive volcanoes on the planet. They are so incredibly violent that when they erupt, they don't even bother building a mountain. They just self-destruct. They blast out so much material so fast that the ground literally collapses in on itself to form a massive depression. It's pretty terrifying, but it tells us something crucial. The magma chamber fueling that blast is unimaginably huge, and it sits uncomfortably close to the surface.
Moving right along to Section 2, lava floods and ocean ridges.
So what happens when lava doesn't just build an isolated mountain, but completely floods an entire landscape? We really need to zoom out our sense of scale for this one. Flood basalt provinces are just mind-bogglingly huge. We're talking absolute oceans of highly fluid lava traveling immense distances, literally covering thousands of square kilometers. And we aren't talking about a thin crust either. Individual flows can stack up to over 50 meters thick, stretching for hundreds of kilometers. A perfect example is the Deccan Traps in India, which currently covers most of the Maharashtra plateau, and geologists are pretty sure it used to cover a significantly larger area than it even does today.
And then there's this staggering number, 70,000 kilometers. While we're usually totally obsessed with volcanoes on land, there's actually a massive system of mid-ocean ridge volcanoes stretching over 70,000 kilometers across all of our planet's ocean basins. It's literally a continuous seam wrapping around the globe underwater, and the central portion is constantly erupting, generating brand new ocean floor as we speak. So we've got explosive mountains, sunken calderas, and literal oceans of lava. But what about the lava that never actually makes it to the surface? What happens when all that incredibly hot, pressurized rock gets trapped and cools in the dark, miles below us?
That brings us to Section 3, Journey Beneath the Crust.
All right, we are heading underground, deep into the crust where the Earth's hidden architecture is really forged. There's a simple distinction here that is basically everything in geology. All cooled magma becomes igneous rock, right? But where it cools changes its classification entirely. If lava erupts and cools up on the Earth's surface, it forms volcanic rock. But if that lava gets trapped and cools slowly deep down inside the crustal portion of the Earth, it creates plutonic rock. Because these plutonic rocks form by intruding into existing rock layers, we call them intrusive forms.
So how do we even know these deep, frozen magma chambers exist? Well, it happens in steps over millions of years. First, a massive pool of magma cools deep within the crust, forming huge granitic bodies. At this point, they're completely hidden. Then, step 2 kicks in, denudidational processes, which is just fancy geology speak for erosion. Strip away miles of overlying rock and soil over vast amounts of time. Which leads to step 3. Those massive granitic domes, called batholiths, are finally revealed on the surface. You are quite literally looking at the fossilized remains of an ancient magma chamber.
To put this massive geological concept into a real-world perspective, take the Karnataka Plateau in India. If you visit, you'll see it spotted with these beautiful domal hills of granite rock. They just look like regular hills, but they're actually exfoliated batholiths, or their slightly smaller cousins, laccoliths. A laccolith is basically a large, dome-shaped intrusive body with a flat base fed by a pipe from below. It's a localized ancient pool of lava. So if you're ever walking on those hills in the Karnataka Plateau, remember, you're actually hiking on top of a frozen underground bubble of magma.
Let's dig even deeper in Section 4, Hidden Underground Landforms.
Now, when magma pushes upwards, it doesn't always form a nice, neat dome. Often, it just kind of hunts for weak spots in the existing rock and squeezes into some really wild geometric shapes. If the magma settles into a saucer shape that curves up toward the sky, we call that a lapolith. If it forms a wavy mass, usually found resting at the base of synclines or the top of anticlines in folded country, it's a facholith. And those wavy facholiths always have a conduit feeding them from a deeper chamber. Then if the magma just spreads out flat horizontally like a floor, it's either a sill or a sheet. The only difference is thickness. A thick horizontal slab is a sill and a thinner one is a sheet.
But what if the magma doesn't go horizontal? Sometimes, lava forcefully blasts its way up through vertical cracks and fissures in the land. When it cools and solidifies right there, almost perfectly perpendicular to the ground, it forms a massive, solid wall of rock. We call these vertical geological walls dikes.
And here is where it all ties together, which is just absolutely fascinating. Remember those massive flood basalts in the Deccan Traps of Maharashtra we talked about earlier? They didn't just magically appear out of nowhere. Those vertical walls we just mentioned, the dikes, are actually extremely common in western Maharashtra. Geologists have realized that these very dikes were the massive underground pipes, the actual feeders that fueled the unimaginably huge eruptions of the Deccan Traps.
As we wrap up today's explainer, I really want you to think about this incredible, invisible world we just mapped out. From those explosive composite volcanoes towering above us, down to the silent, saucer-shaped lapoliths buried deep in the dark crust. I hope you look at the ground beneath your feet just a little bit differently today. Because knowing that the hill you hike on might be an ancient batholith, or the bedrock below you could be a vertical dike that once fed a literal ocean of lava, it really makes you wonder, doesn't it? What hidden geological structures are sleeping right beneath your own hometown? Keep exploring, keep questioning, and I'll catch you in the next explainer.